Okay, good day to each and every one of you. I have here another problem concerning about the actual stresses of a truss system. I have here the free body diagram of the structure. We have here at point A and point F, which has its corresponding supports. For point A, we have here a pin, and then for F, we have here a roller. And this is the structural geometrical shape of our truss. So we have here 8 feet for AB, 6 feet for BC, 8 feet again for member BE, and then 8 feet again for member EF, and 6 feet for member DE. And we have here an applied load 30 kilopounds or 30 kips, or you can just simply say that is approximately 30,000 pounds of force acting here on point E. And then each structural member has a cross-sectional area equivalent to 1.8 square inches, and the required is simply to solve for this following parameters. We have here the internal force at the member CE, internal force at member DE for DF, and of course the corresponding axial stresses imposed on each required member. So we have sigma C sub E, sigma D sub E, and then sigma D sub F. So all we need to do is to solve for each member and its corresponding axial stress, kaya normal stress. So I hope you can simply see this free body diagram. And the first thing here to consider is that what should be the first step in solving truss problems. So the first step again here is to solve first the reaction points. So those reaction points will be at member A, this one, AB. We have here the pin for point A, and then of course for point F we have a roller. And then we all know that all of the loads is just basically acting on the y-axis, so we don't have any forces acting on the x-axis. And that's what makes it easier kasi we don't have any forces along the x-axis, we only have at the vertical. So let's try to solve first for the members A, the reaction points here at the endpoint A, and then for the endpoint F. Now we have here the pin, and then we have the roller. So let's try to solve for that one. I'm just going to set aside this for now. And again, let's try to do the free body diagram. Let's just imagine we have here the point A. Okay, this is point A, and we need to extend just a bit. Then this is point F, and we can just simply exclude first those members because what we need to do is to simply solve for the reaction points, diba? So we have here, this is point E at this section, and then we have this member. This is 8 feet, this is 8 feet, and then of course this is also 8 feet, and we have here another member going like that, and then like this, and this one is 30 kips or 30,000 pounds. All we need to do is to solve for this one, R sub F, and this one, R sub A. Okay. And what are we going to do from this point? So this is B, then this is point D at this portion, and then this is C. Now, this is fairly easy problem because it doesn't involve a lot of complicated formulas. It's all about applying the laws of statics. Okay, what is the first step here is we can somewhat solve for either reaction A first or here at reaction F. Depends on you whether you are convenient. Kung saan kayo mas madali. Okay, let's try to solve. Let's try to eliminate first one of the unknowns because we cannot directly solve each reactions here because we have two unknowns. Okay, that's why we need to apply first the principles of moments. So by doing that, Let's try here at A, or if you want, you can also try here at F. So the summation of forces, moments acting at point A. So M sub A is equals to 0, because all of the moments should be 0 so that our structure is static. C is equals to, this would be 0 because this is our pivot point. And then we have here 30 kilopounds rotating clockwise, so that would be positive. So 30 kips multiplied by the moment arm, 8 and 8, so that should be a 16. Be 16 feet, and then minus, because r sub f rotates counterclockwise. That's r sub f multiplied by the moment arm, that should be 8 times 8 times 8, so 24 feet. Then r sub f, and then let's try to isolate r sub f. R sub f, 24 feet, is equals to simply multiply 30 and 16. And 16. And then r sub f is equals to, divide both sides by 24 feet. So 30 kips, or 30 kilopounds, multiplied by 16 feet, divided by 24 feet. It's all about algebraic operation. Cancel the feet. The remaining unit is in kilopounds. So r sub f is basically, so let's go with this one. R sub f is equals to, that should be the answer for this one upon simplification. That is 20 kips. That's 20 kilopounds basically. So we have here r sub f is equals to 20 kilopounds. And then if we somewhat manage to solve for r sub f, this is 20 kips. Let's try to solve for r sub a. I'm just going to erase this one since we already somewhat managed to solve for r sub f. So going to erase this just to have additional space. Okay, so I think that's enough. Let's solve for r sub a. We just need to apply the summation of forces along the y-axis. So it should be summation of forces along the y-axis equals to 0. And upon doing that, just need to add all of the forces acting on the y. So that should be r sub a positive minus 30 kilopounds, 30 kips, and then positive 20 kips because it's going upward, plus 20 kips, and substitution, or rather transposition of 30 kips and then 20. So making it r sub a here is equals to 30 kips minus 20 kilopounds, or 20 kips if you want. Then r sub a is basically 30 minus 20, equivalent to 10 kilopounds. So this is the reactions at for F and for A. So we have here 10. Let's try to designate that as 10 kilopounds because we already know what is the unit. So let's try to erase this again because we already managed to solve for the reactions. So for R sub A is 10 kilopounds, and then for R sub F is equals to 20 kilopounds. Just going to erase this one so that we have enough space for answering the rest of the members. So that's for the first part, solving for the reactions. And then now, for this part, we need to solve for members DF, for members DE, and for member CE, because this is point E. And we have 3 members required: DF, DE, and CE. So what is the easiest member that we need to solve first? So according to this case is that we need to look for the most convenient member, which is the most easiest one to solve. Because if we directly go into the members that is somewhat inside the structure, that would have a bit more complicated approach because we have many unknowns. So that's why for this case, let's try to solve first member DF because that is the member that is closest to have any data available in order for us to solve for the whole structure. What I mean to say is that if we have any information regarding the structure itself, like for example here member DF, if we have this R sub F at this point and then it is somewhat near to member DF, then we can just somewhat solve for the force that is acting at member DF because we have this 20 kilopounds. If we directly go to member DE, we don't have any information regarding the forces that is being imposed on members DF and member EF, which is a bit difficult because we don't know the internal forces that is acting on these set of members. So that's why we need to go to the member that has any available data. Okay? That would be part 1 of this lecture.